Wala pa, Zaira. All right, so I think we are recording now. Good morning again, everybody. Welcome to the second week of Math 151. Some housekeeping announcements. I already scheduled the midterm and the pre-final exam. So kindly take note of these kasi nga face-to-face yung exams natin. So please make plans for October 31 and December 12, 10 to 12 noon. Right. So again, on October 31, 10 a.m. to 12 noon, we'll have the midterm exam. And on December 12, that's also on Monday, pareha silang Monday, 10 to 12 noon din ang ating exam. Room to follow, right? Pero tatlo lang naman yung pagpipilian na room sa math building kasi nga may demolition magaganap sa math building, so limited yung options natin. But I'll let you know siguro a week before kung ano yung final room assignment natin. Pero for now, make arrangements for October 31 and December 12. Both are Mondays. Dapat nasa math building kayo ng 10 to 12 noon for our face-to-face exams. And remember, the face-to-face exams are a big component of your grades. 60% yon, 30% each. So make sure you take both of those exams, all right? So let me know if you will have some problems with that para mas-solutionan kagad natin. Pero ngayon pa lang, try to make arrangements for those dates, all right? Now, also, in the middle of the presentation, meron tayong pop quiz, para wala muna tayong homework for this particular, wait, hold on. Pag-isipan ko pala yun. Pero medyo may amendment pa ako na ipropose dun sa grading scheme natin. So 20% I remember is for homeworks, 20% would be for the final project. Tama nga ba? 60-20-20 tayo, ano? So dun sa 20% for the homework, magdadagdag ako ng quizzes. So quizzes and homework, 20%, and then final project, 20%. Or gusto nyo bang bawasan ng konti yung final project? Siguro pag-usapan later. Pero yun nga, magdadagdag tayo ng component, quiz, which will be the lectures. Okay? Para hindi ko kailangan mag-check ng attendance. Kasi card na rin naman ng attendance. So, yun. Right. Again, mag-start na ako ng share. Medyo late ko na sisimulan yung share screen kasi when some people enter the meeting after start of the shared presentation, medyo nakaka-problema. Hindi nila nakikita yung naka-share na screen. Okay, email ko yung nakalabas. Pero I hope you can now see my screen. Tama ba? Wala pa ako nakikita dun sa isa kong monitor. Pero I hope you can see a PowerPoint slide. It says 151. Can you guys see it? Hindi pa. Where's it looking? Wala pa? Blanco lang din. Or picture ko lang yung nakikita. Wala pa. Hold on. Ano nangyari? Let me try again. So I think it is okay now. Right. Just let me know kung merong problem, kung hindi nyo nakikita yung naka-share screen. So, hold on. Meron lang itatry. Kaya ba natin i-annotate ito? Okay, let me just try this one. I'm trying the screen annotation feature of Teams. Okay. Medyo matagal pala siyang mag-load. Pero tingnan natin. Okay. So today we'll start our discussion of Chapter 1 of Math 151. So as I've mentioned in the orientation last time, Math 151 is all about solving ordinary differential equations. But before we can have a meaningful discussion of the solution methods for various ordinary differential equations, kailangan magkaroon muna tayo ng strong understanding about what ordinary differential equations are, what are the solutions that we are looking for, and ano yung ibig sabihin pag sinabi nating solutions. Ano? So yun muna yung gagawin natin in the first chapter. We will just be acquainted with the general theory of the solutions of differential equations. Ano yung itsura nila? Basically, ano yung mga different classes of ordinary differential equations and the like. So mukhang introduction lang tayo this week. Medyo mas magaan pa to compared to next week's meeting. Ano? So, okay, so this is chapter 1. Oh, by the way, I already uploaded a copy of the handout dun sa module 2, all right, or week 2 section ng module, so you can download it there. I posted two versions, isang PDF file na 2 slides per page kung medyo gusto niyo malaki yung nakikita or gusto niyo malaking space to annotate within the slides. And I also have, kung mas gusto niyo yung printed, I also have 6 slides in a page. So para tipid sa number of pages. Ano? If you have some other suggestions about the format, just let me know later. All right? So chapter 1, the basics of ordinary differential equation. Pag sinabi nating basics, ano lang to? A general theory, a general description of what ordinary differential equations are. So it will have the following components. So we'll look at the definition and examples of differential equations along with some classification or types of differential equations. And then we'll look at the geometric interpretation of first order ODEs. And next we'll look at family of curves. Ano? I hope you started familiarizing yourselves with MATLAB kasi may certain components na mag-i-insert ako ng MATLAB. And I think the first one would be on getting a geometric interpretation or the family of curves for different solution of ODEs. Tapos pag tingin natin ng isoclines, pag tingin natin ng direction fields, ano? So medyo mag-rely tayo sa MATLAB as our graphing software. But if you can do it in other softwares, that's fine. Pero yung ide-demo ko sa klase siguro MATLAB. Tapos from time to time, I'm gonna share with you some programs na mag-run sa MATLAB para sa pag-solve ng ODEs, direction fields, and so on. All right? So you can get started with it, pero siguro next meeting or next week simulan ko yung paggamit ng MATLAB. All right? Now, the objective for today's meeting are as follows. At the end of this lecture, you should be able to define some basic concepts and definitions for differential equations. And to test kung magagawa niyo na talaga to, siguro towards the end of this PowerPoint slides, I do have a Slido quiz. So mamaya, I'll request you to open another tab on your browsers, or if you have your phones with you and you have internet access on it, so mag-Slido tayo mamaya para sa ating pop quiz for today, right? So kaya kailangan makinig talaga kayo kasi meron tayong quiz mamaya. Dapat surprise quiz, pero dahil second week pa lang naman to ng classes, I'll give you the slack. Sabihin ko na, merong quiz, so pay attention. All right? Okay, so let's start off with some basic stuff here. What is a differential equation? Hold on. Medyo hindi ko siya ma-move. Pero the slide says that a differential equation, in short, a DE, is an equation containing the derivatives of one or more unknown functions with respect to one or more independent variables. This is what I'm telling you last time. Ito yung kaibahan ng differential equations mula sa algebraic equations. Sa algebraic equations, puro variables at constants lamang yung nakikita natin. Pero when we go to DEs, sa differential equation, laging may derivative na kasali. And it could involve a function of one or more variables. So kapag isa lang yung variable, isa lang yung klase ng derivative na makikita natin. But if our function consists of several variables, ibig sabihin meron tayong mga partial derivatives na pwedeng kasama dun sa differential equation. Some examples of differential equations are as follows. dy over dx equals 3x squared. Ito ay differential equation kasi nandito yung derivative na dy over dx. All right? So involved siya dito. So basically here we're asking what is a function y na ang derivative niya with respect to x ay equal kay 3x squared. Another example, y triple prime equals 3x squared y minus xy. oops, meron kagad derivative, automatic. It's a differential equation. It doesn't matter how high the order of the derivative is, basta may derivative, pasok siya sa differential equation, right? And it doesn't matter how the other terms in the or the other quantities in the equation look like, all right? So basta meron derivative, yun lang yung hanapin nyo. Magkaroon man siya ng derivative o kahit differential nga lang, consider na siya as differential equation. Okay. And as I mentioned earlier, it doesn't have to be just a function of one variable. So we can have a function u of two variables, tapos meron kang partial derivative of u with respect to the variable t, tapos kasama rin yung partial derivative with respect to the variable x. So that means number 3 is still a differential equation. Again, madali lang silang ma-spot. As long as you see a derivative in the equation, then it's considered a differential equation. Okay? Now, sabi ko kanina may exemption. Hindi kailangan eksaktong derivative yung makita nyo. Posibleng differentials yung makita nyo. So we look at example number 1. Sa example number 1, makikita natin you have dy over dx equals 3x squared. We can write it in differential form by considering dx as a separate quantity. So di ba meron tayong interpretation, dalawang interpretations sa dy over dx. You can think of it as the derivative of your function with respect to the variable x. So that means dy over dx here is considered as a single entity. Pero when we talk about differential sa Math 36, meron pa palang isang interpretation yung dy over dx. It can be interpreted as the ratio between the differential of y and the differential of x. Medyo meron nga lang technical assumptions behind that interpretation, but nonetheless, you can treat them as two different quantities. So what you can do here from the example number 1, we can multiply both sides by the derivative of, by the differential of x. So essentially, multiply mo lang si left saka si right-hand side ng dx. You treat dy over dx as if it's an ordinary fraction. So you can write it as dy equals 3x squared dx. So yun tinatawag natin na differential form ng ating differential equation. So, meron dalawang criteria or two possible things to look for para masabi kung siya ay isang differential equation o hindi. Dapat meron siyang full derivative of any order, or be it a partial derivative, that's also fine as long as meron derivative, or pwede rin namang differentials yung involved. Pero kung may differential, yung independent variable, dapat meron din differential yung dependent variable, at least for the cases that we will consider in Math 151. All right? So, oops, paano ko ito i-clear ngayon? Okay, there we go. So, a differential equation helps us understand phenomena that involves rates of change. Kaya nga sabi ko kanina, kadalasan yung mga meaningful models sa totoong buhay, be it in the physical or the natural phenomena, ay laging in terms of a differential equation. Kasi nga everything changes through time, through space, or with respect to some other variables. As long as there is a change involved, laging differential equation yung meaningful model para sa kanya. Some applications can be seen, say, in the spread of diseases, population dynamics, planetary motion, traffic flow, chemical reactions, physical laws, stock markets, electromagnetic waves, acoustic waves. Yun yung mga bias ko. Yung dalawa na yun. Kaya i-insert ko siya supposedly dito. But anyway, these are some things kung saan pwede nyo gawin yung inyong project. Ano? So in our final project, we'll look at specific problems in these areas or some other physical or natural phenomena. Magmamodel tayo using differential equations, and then you'll try to solve them, tapos i-interpret nyo yung solutions na makukuha natin. All right? I'm still thinking whether to give you the liberty of picking up your project topic or kung ako na lang yung magbibigay ng project topic. All right? So, but let me think about that. Probably in a couple of weeks, I'll finalize the plans for the final project. Pero essentially, ganon yung mangyayari. Okay. May isa pa, weather and climate predictions. Now, we will now look at some classifications of differential equations. Medyo broad pag sinabi nating differential equations. But one thing that we can say is may dalawang klase. may dalawang umbrella types of differential equations. Yung una, yung ordinary differential equations. Pag sinabi nating ordinary differential equations, isa lamang yung variable na involved. Isa lang yung independent variable. So it involves looking for a function of a single variable that will satisfy the differential equation. Kaya siya ordinary kasi ordinaryong derivatives lamang yung involved. Kasi isa lamang yung independent variable. For instance, d squared y over dt squared plus dx squared over dt squared equals x. So in this particular case, isang klase lamang ng derivative yung involved. Derivative with respect to the variable t. Right? So isa lang yung dependent variable, and in the way we phrase it, we are assuming that the functions y and x are both dependent on the variable t. Isang klase lamang ng derivative yung involved dun sa problem. And in this particular case, derivatives siya with respect to the variable t. Even though we have two other variables involved, y and x, pero in the way the problem is phrased, dahil kinuna natin sila ng derivative with respect to time, or with respect to t, the assumption is that both y and x are functions of the independent variable t. Dahil isa lamang yung independent variable, with respect sa isang variable lang tayo nagde-differentiate, then this is an ordinary differential equation, or an ODE for short, in short. Okay. Another example is d squared y over dx squared plus dy over dx equals 3. In this particular case, there are two different derivatives. We have a second derivative with respect to x and a plain old first derivative with respect to x, but the thing is, parehong derivative ay with respect lamang sa variable na x. So that means there's only one type of derivative involved. We can look at problem number 2 to be simply an ordinary differential equation with respect to the independent variable x. Kasi with respect sa isang variable lang tayo nag-differentiate. Okay? So yan yung mga ordinary differential equations. The other type, hindi special differential equation, ang tawag dun sa isang type ay partial differential equations. Partial differential equations because it is a function that contains some partial derivatives. All right? So ibig sabihin, marami ng variables yung involved dun sa functions, and the equation will involve a derivative with respect to more than one of the variables involved in the function, right? So for instance, we have this uxx plus uyy. Remember this notation? Yung uxx, ang ibig sabihin niya, siya yung partial derivative ni u with respect to x, tapos ipapartial ko siya uli with respect to x. So basically, this is the second partial derivative with respect to x. And this guy is also a second partial derivative, but this time it's with respect to y. So you take the partial derivative of u with respect to y, then differentiate it again with respect to y. Dahil dalawa na yung variables with respect to which we are differentiating, then example number 1 is a partial differential equation, or is a PDE. Right? So dalawang derivatives yung involved, or derivative with respect to two different variables yung involved. So this is a PDE. Similarly, ito ay u sub tt equals uxx. So second partial derivative with respect to t, second partial derivative with respect to x. Dalawang variables yung pinag-differentiate natin. So ibig sabihin, it is a PDE. And another example, u sub t. So this is the partial with respect to t equals the second partial with respect to x. Again, two variables involved in the differentiation. So this is a partial differential equation. All right? And you might be thinking, mas mahirap nga ba mag-solve ng PDE? In general, yes. All right? So lucky for us, this course is only intended as a solution course for ODEs. Kung medyo interested kayo sa PDEs, you need to take Math 152, right? Na ang prereq ay 151. But for this particular course, lucky for us, ODEs lamang yung isolve natin. Pero as we go along, you will realize na kahit ODEs lang pala yan, medyo maraming solution schemes and most of the solution schemes will depend on how how the derivatives look like. Right? Kaya nga, una natin gagawin, magka-classify muna tayo ng mga ODEs because the type of ODE will dictate ano yung solution scheme na pwede natin gamitin to solve them. Right? So that's ordinary versus partial differential equations. I guess these are self-explanatory, but if you have some questions, don't hesitate to raise it, right? Questions so far? Wala pa naman? Everything's looking good? Hopefully. Ito yung problema ko sa online class eh. Hindi ko makita yung mga itsura nyo. So hindi ko alam kung nakakunot na yung mga noo nyo or nakasimangot na kayo. At least now. Yeah, thank you. At least now you're reacting. So yeah, keep those reactions going. All right, so some notations that will help us or that will guide us through our study of ODEs. May iba't ibang klase ng notations para sa derivatives. Minsan bias ako dun sa tinatawag nating Lagrange notation kasi ito yung medyo pinakamadaling isulat at pinakamadaling i-type sa latex. So yung mga nag-174, sawa na kayo kay Lagrange or magsasawa kayo kay Lagrange. Pero this is the Lagrange notation for the derivative. Pangit pala yung highlighter nito. So anyway, yeah. Y prime, Y double prime, Y triple prime, and then kapag mas mataas na sa third order yung derivative, parang exponent yung ginagamit natin pero naka-enclose in parentheses. So be careful if you want to denote the fourth derivative of say a function f, lagi niyo siyang i-enclose sa parentheses. So yan yung fourth derivative. So as not to create a confusion, with f to the power 4. Okay? Yung f to the power 4, iba siya dun sa fourth derivative. Okay? Don't forget the parentheses for that. So this is the Lagrange notation. Unang notation, ito yung ginamit ni Newton. Instead of an apostrophe, ang ginagamit niya ay dots dun sa ibabaw. So yung y dot, siya yung first derivative ni y with respect to the independent variable. Y double dot, ito yung second derivative, and so on. So ito yung medyo ginagamit sa physics. And usually, kahit sa engineering pala, gumagamit din sila nito. But usually, they reserve the dot notation as derivative with respect to time. Right? Lalo na kung PDEs yung sinosolve. Sa PDEs kasi maraming variables. So yung dot, nire-reserve para sa temporal derivative or the derivative with respect to time. Pero pag ODE lang naman, isa lang naman yung isa lang naman yung klase ng derivative na pinaglalaroan natin sa yung y dot understood to be the derivative with respect to whatever the independent variable is. Okay? So Newtonian Newtonian convention. And then the next is the Leibniz notation. Ito yung ito yung dy over dx para kay first derivative with respect to x. Ito naman yung second derivative and so on. So just make sure tama kung saan nakalagay yung parang exponent dun sa Leibniz notation. Dun sa differential with respect to the dependent variable, yung power or yung order nakalagay dun sa D symbol. Alright? Pero dun sa dun sa differential ng independent variable, nandun sa variable yung exponent. Medyo may technical meaning kung bakit ganyan yung notation. Probably I can share it with you if we'll have time later. Pero kasi ito yung parang operator form. Nung derivative, yung d cube over dx cube. Tapos ini-input lang natin yung function na y. Alright? So ito yung Leibniz notation. And I find the Leibniz notation preferable if you want to emphasize with respect to which variable you are differentiating. Right? Kasi medyo explicit yan. Kita mo kagad sa problem with respect sa ang variable ka nagde-differentiate. And it is also in preparation for expressing the ODE in differential form. Right? Yung magkahiwala yung dy at saka dx. Because at some point in the course, mas preferred natin na gumamit ng differential form kaysa dun sa derivative form ng ODE. Right? So we will look at we will use these notations interchangeably throughout the course. Pero siguro yung bias ko ay yung Lagrange kasi nga siya yung pinakamadaling isulat at i-type. Alright? Pero at some point, medyo convenient din gamitin yung Leibniz. I am not particularly into using Newtonian notation, all right? Lalo na kung ODE lang naman, medyo kasi luma or old school yung Newtonian notation. All right? Now, what's next? All right. So some definitions that will help us describe our ODE. Right? First is the order of the ODE. The order of a differential equation is the order of the highest order derivative appearing in the equation. So remember, an ODE is anything that involves a derivative. We are not choosy on what type of derivative, what order of the derivative we have in the problem, right? So yung order ng isang ODE ay yung pinakamataas na order ng derivative na nandun sa equation. For instance, if we have this, so there's only one derivative involved, and that's third order. So we say that this example is an order 3 ODE. Kasi order 3 yung pinakamataas na derivative. This one, y prime to the fourth equals 3x squared minus xy double prime plus y. What do you think is the order of this derivative? Sige nga, anyone? Come on, guys, bonus points. Chriselle is saying 2, Justin ay 2 rin. Dino, Christine, walang magsasabi ng iba. All right. So why do you think this is of order 2? Sige nga. Anyone who wants to explain? Unmute nyo lang yung sarili nyo or type in the chat box. Bakit order 2? Kasi okay, Chriselle is correct. Kasi meron kang y double prime. Yung napilitan si Victor na magpalit ng guess. Sabi niya ay 4 with a question mark. It's not 4 because the order refers dun sa order ng pinakamataas na derivative. Probably you're thinking about this expression here, y prime to the fourth. Okay? Siya ay merong 4 na merong number na 4 pero yung 4 na yon ay exponent. All right? This is the first derivative raised to the fourth power. So the degree of the derivative is different from the order of the derivative. It is simply the first derivative raised to the fourth power. That will not change the order of the ODE. Kasi ang usapan natin, yung order, siya yung order ng pinakamataas na derivative. So the left-hand side is an order 1 derivative, yun nga lang raised siya dun sa power na 4. All right? So it won't change the order of the derivative. Order 1 pa rin yan, kaya lang meron siyang degree na 4 or meron siyang exponent na 4. Then naman sa right-hand side, meron tayong y double prime order 2. So the left side contains an order 1 derivative. The right-hand side contains an order 2 derivative. So the higher is 2. So that means this ODE is of order 2. All right? So I hope wala nang mabibiktima kapag ka naglagay ako ng exponent sa derivative, hindi niya binabago yung order ng derivative. So ang usapan, pang ilang derivative yung pinakamataas na makikita nyo doon sa equation. All right? Okay, next one. Y double prime to the 6 equals this guy. So what is its order? Sige nga. Kapag mga madadali lang naman ganito, you can abuse the chat box. So I'm seeing 5, 5, 5, 5. All right. Yan, natuto na kayo, ano? So derivatives lang ang usapan, walang pakialaman ng exponent. So the left-hand side is a second order derivative. It is raised to the 6th power, but it doesn't change that the left-hand side is order 6 derivative, order 2 derivative lamang yung involved. Whereas on the right-hand side, we have a 5th order derivative. So the higher is 5. So this is of order 5. So it's an order 5 ODE. So ngayon, dalawang bagay na yung pwede niyong tingnan. Yung order at saka yung degree ng mga terms na involved doon sa ODE. Pag order, ang titingnan nyo lang pang ilang derivative yung pinakamataas. Wala tayong pakialam dun sa degree ng mga terms na nandoon. All right? Details, ano? Okay. Okay, so let me just see. All right, another way to write an ODE is in operator form, right? So pwede ko siyang isulat as a function or an operator f. So pwede kong i-isolate. Dun sa left hand, lahat ng involved lamang yung dependent variable and its derivative. Tapos ihihiwalay ko sa right hand side yung walang dependent variable na involved. Right? So this side, i-collect ko lamang lahat ng mga y's yung involved. Or lahat ng may mga y's. Lahat ng terms na may y, ilalagay natin sa kaliwa. At yung function na yon, tatawagin nating big F. And so this big F involves the variable y, y prime, y double prime, and all the derivatives. Sorry, ako yung nag-read. Sabi ko pa naman kanina magkakalimot yung exponent, pero ako yung nakalimot. So dapat may exponent. Right? So that's the, may parentheses, yung n dun sa y to the n. So it's the nth order derivative. So, pero si y, remember si y ay dependent kay x. So ibig sabihin si capital F, yung left-hand side natin, posible pa rin siyang magkaroon ng mga variable x. Basta meron siyang multiplier na dependent variable y. So essentially, what we are doing here in the operatorial representation of the ODE, lahat ng terms na involve yung dependent variable and any of its derivatives, ilalagay natin sa kaliwa. Yun yung function big F. Tapos lahat ng walang y, lahat ng nakadepende lamang dun sa independent variable x, yun yung ilalagay ko sa right-hand side. In this particular convention, the function capital F called operator dun sa ODE. Kasi siya yung nagsasabi paano nagbe-behave si function y and its derivatives alongside with the dependent variable. And then the right-hand side, which is the function that doesn't involve the dependent variable, is called the forcing term. Forcing term siya, makikita natin later kasi more on the physical side. Ito yung parang initial So si F na hindi nagde-depend dun sa dependent variable, ang tawag natin sa kanya ay forcing term. Right? So if the forcing term is 0, ibig sabihin walang term na hindi involved si y or any of its derivatives, ang tawag natin dun sa ODE ay homogeneous. Right? Pag 0 yung forcing term, it's homogeneous. Other than that, it is called non-homogeneous. Kapag ka walang term na walang involved na y, walang term na walang involved na y, it means it is that means it is homogeneous. Kapag ka non-zero yung forcing term, it is a non-homogeneous differential equation. Right? Right. Bakit gusto ko ng operatorial form? Because most of the interesting properties about ODEs and its solutions, including existence, uniqueness of the solutions, can be gleaned on the operator F and how it looks like. Makikita natin later na kapag meron tayong non-homogeneous differential equation, kailangan ko munang isolve yung homogeneous equation, tapos mag-add lang ako ng particular solution dahil dun sa forcing term. Pero essentially, lagi nating tinitingnan yung operator F, and usually the type of solution that we need to employ for a particular ODE and the number of expected solutions will all depend on how the operator F looks like. Kaya importante yung pagsusulat ng ODE in operatorial form. Okay, so let's look at a couple of examples here of writing ODEs in operator form. So number one, find the operator for the following ODEs. So remember, the operator is simply kukunin sa left-hand side lahat ng involved si y at saka yung mga derivatives niya. Kasi iwanan ko sa right-hand side yung walang involved na dependent variable. But I'm not, nasaan na ba ako? Nasa let's try this na ako. Kasi dun sa slides ko sa tablet, nandun pa rin ako sa, ayan, nag-move na siya. Okay. Okay, good. So again, yun lang lahat ng may dependent variable at saka yung mga derivatives ilalagay ko sa kaliwa. lahat ng walang dependent variable, ilalagay ko sa kanan. Alright? ODE natin, y prime equals 4e to the 2x minus 6e to the negative 2x. Oops, delay talaga yung screen ko. Ang ating dependent variable ay y. Right? Y lamang yung dependent variable. So lahat ng involved si y, ilalagay ko sa left. Pero luckily, nandito siya. Tapos dun sa kanan, wala na akong kailangang ilipat. Y. So that means our big F here is simply a function of y prime. Kasi siya lang yung function na nandun. So this is equal to y prime. Tapos yung forcing term natin, little f of x, ay 4e to the 2x minus 6e to the negative 2x. So what can we say about number one? Is it homogeneous or non-homogeneous? So you have a non-zero forcing term. So the first differential equation is called a non-homogeneous differential equation. Kasi hindi zero yung kanyang forcing term. Right? Now for number two, d squared t over dt squared. So we're taking the derivative with respect to t. So understood na dito na ang ating variable is t and our dependent variable is v. Ang usapan, lahat ng merong dependent variable, kailangang ilipat sa left-hand side. Look at the side of the original form, t squared v, involve yung variables, you need to transpose it to the left hand. This later for the second differential equation, to write it as d squared over dt. Pero anyway, try ko nga dito sa screen. Okay. Tapos kailangan ko ilipat yung t squared v kasi involve yung dependent variable. So there would be a minus t squared v. Pangit pa rin yung sulat ko. But anyway, and this is equal to 0. Right? And then this guy, ito yung ating operator. This is our function f of v and v's double prime. Right? Pwede nyo rin sa si t, alright? Kasi merong variable t, the dependent variable is involved in the left-hand side. So pwedeng yung capital F isama nyo as a function of t, alright? V double prime, and t. Na-require ako na ilipat yung dun sa left-hand side kasi involved sa kanya si v. Kahit t squared siya pero involved si v, dapat isama ko siya dun sa operator capital F, right? So this is our operator capital F, this entire guy, and our forcing term is 0. Kasi walang term na involved lamang ay yung independent variable t. So that's why number 2 is called a homogeneous differential equation. Homogeneous na ODE siya kasi 0 yung forcing term. Okay. And then the last one, can anyone tell me if number 3 is homogeneous or non-homogeneous? Number 3 na tayo. Homogeneous or not? So kung sasagot kayo, lagyan niyo ng number para alam ko kasi ang haba na pala ng chat box natin, ano? So number 3, is it homogeneous or non-homogeneous? Sige nga. Okay, homogeneous. Oh, halo-halo. May homogeneous, may non-homogeneous. Okay, usapan lagi. Kolektahin lang ng involved yung independent variable sa kaliwa, yung dependent variable sa kaliwa. Lahat ng independent variable lamang yung involved ililipat sa kanan. So here, y prime. So ibig sabihin, nagde-differentiate tayo with respect to the other variable involved in the problem. So nagde-differentiate ako with respect to t. So ibig sabihin si t, siya yung independent variable. Kasi siya yung variable kung saan tayo nagde-differentiate. So, ang variable natin ay si y prime. So, lahat ng merong y, including its derivatives, kailangan magstay sa left-hand side. Y prime stays on the left. 1 over t plus 1 times y. Because it involves the variable y, kailangan magstay siya sa left-hand side. But look at sine t. Si sine t, siyang dependent variable na involved. Ang involved lamang kay sine t ay yung independent variable t. So this guy should go to the right-hand side. So the operator for the third example is y prime plus 1 over 1 plus 1 over t plus 1 times. And then the forcing term is negative sine t. Right? Lipat siya dun sa kabila. So dahil ang forcing term natin ay negative sine t, this one is non-homogeneous. Kasi hindi zero yung forcing term. Alright? I hope that is clear. Or nakakalito ba yung homogeneous at non-homogeneous? Zero forcing term. Non-homogeneous, non-zero forcing term. All right. So some more classification schemes for ODEs. So in general, though nakita na natin to kanina. So ito yung nth order ODE. Okay. So another type is an explicit ODE. We can say that an ODE is explicit if we can write, right? If you can write it in this form. Ang is ODI explicit. I wish way the highest can be isolated on the left-hand side. Right? Kapag kaya kong isulat yung ODE such that yung pinakamataas na order and dun sa left-hand side, tapos lahat ng mga derivatives at ilang pang mga terms ay nandun sa kanan, then it is explicit. If I cannot write it in explicit form, then it is said to be implicit. All right. Some example. Okay. So an example of an explicit ODE is this guy. Kasi kaya ko siyang isulat as the highest derivative equal to all other terms. Right? Kasi ito ay order 1 differential equation lamang. Kasi highest order ay 1. Ito-try ko ngayon na i-isolate si y prime, yung highest order dun sa left-hand side. Because I can do that y prime equals x sine y is an explicit. Delayed yung shared screen. Bakit kaya? Let's see. Sige, ayun lang natin siya. Darating din yun, guys. May nangyari. Hindi na siya nag-move. Let's see. What happened? Okay, there we go. Sorry, siguro sa internet connection ko. So, thank you for reminding me na kung very delayed siya. No? So, hopefully, yan. Nakita nyo na yung example ng explicit. Ito nga example, just to reiterate, kasi delayed yung kanina. Right. So, explicit ang isang OD isolate yung derivative of the highest order on 1. Or kung ganun yung pagkakasulat niya. So, this example, siya ay order 1. Kasi ang pinakamataas na derivative ay order 1. Ang goal, sulat siya in explicit form, kailangan i-isolate ko yung first derivative sa left-hand side. And that is already done in here. So this is an explicit form. In contrast, dun sa implicit form. Sa implicit form, hindi pa na-isolate yung highest order derivative doon sa kaliwa. Right? So in particular here, anong order nitong differential equation na to? Sige nga. Would you agree that this is of order 1? Dapat mag-agree kayo? Kasi yung highest order dito, derivative lamang yung involved. Right? Hindi pa siya naka-explicit form because the first derivative is not isolated on the left-hand side. Sige sir, hindi pa pala siya isolated. So what if I root of power, kakaroon ako ng square root dyan sa right-hand side. Can I now consider this new equation explicit form? Explicit form na ba yan? Sabi ni Reynald, yes. Others, what do you think? Explicit na ba yung dy over dx equals square root na negative e to the dy over dx? Explicit na? The answer is hindi pa. Hindi pa siya explicit. Bakit hindi pa siya explicit? Kiefer, gusto mo i-explain?
Kasi po sir, yung square root, di ba po?
Mukhang hindi makapag-open. Yeah, go, Kiefer. Sorry.
Yung square root po kasi di ba parang ni-raise po siya sa power of 1/2 lang po siya. Pero yung exponent pa rin po yung square root. Pero yung order pa rin 1 po yung nasa right hand side po.
Okay, great. That's correct. Thank you, Kiefer. Kasi ano yung order ng derivative? First order. Para masabi na siya ay explicit, dapat yung derivative of the highest order ay isolated dun sa kaliwa. Alright? So dito, okay, na-isolate ko nga yung dy over dx, pero meron pang order 1 derivative na natira dun sa left-hand side, dun sa right-hand side. Dapat right order na ng derivative ay order n minus 1. So tama yung observation ni Kiefer na, dahil dito, na-raise man siya sa 1/2, meron kang dy over dx na naka-isolate dun sa kaliwa, pero may natira pa na order 1 derivative dun sa kanan. Meron ka pang dy over dx. Order 1, yung ODE, pero meron ka pang order 1 derivative dun sa kanan, hindi to explicit. And actually, I don't think this equation can be written in explicit form. So kaya ito ay isang example ng isang ODE na hanggang implicit form lang yung kaya nating gawin. Right? Medyo tricky yung mga examples, ano? But hopefully you are slowly getting the hang of it. So implicit rin siya. I don't think there's a way that we can write it in explicit. Okay, some more definitions. Definitions for today. Pause, delete. Let me just stop the annotations. Siguro mas mabilis pag wala tong annotations. Okay, thank you. So mukhang hindi siya sa annotation. Mukhang mabagal lang talaga yung internet ko. So now, all right, so I hope I'm back. Mukhang na-cut off ako doon. So, but I hope you're still seeing my screen. Sabi naman kung nakikita niyo pa yung screen ko. And is it updated? Okay, thank you. So an ODE in 2 variables, usually pag binilang natin yung number of variables kasama yung independent at saka yung dependent variable. So an ODE in 1 dependent and 1 independent variable is called linear if it can be written in form. All right. So this, when we say linear, usually we refer to the dependent variable and its derivatives. So dapat linear lamang yung power nung dependent variable at saka yung mga derivatives niya. Wala pa rin. All right. Sorry, mabagal yung internet. Sige, hold on. Let me restart the sharing. Ang daming factors involved, specifically our individual internet connections. Wala pa rin. Loading. Kung makakaligtas kayo sa quiz, kung ilang minutes na lang. We got 25 minutes left. Nasa slide 13 pa rin ako. So, kamiss naman ng internet ko pag meron ako online quiz eh. Siguro pinagdadasal nyo, no? So, hold on. Naliw ko na lang yung sarili ko. Ang bagal lang yung internet. Siguro next time hindi na PowerPoint ko. Parang hirap ng PowerPoint. Okay lang ba na kita na lang yung gawin kong lecture kesa, or I mean Blackboard type na lecture, wala nang slides. Kasi ang bagal pag mag-i slides eh. Yan nga, matuloy yung wait. Kasi mag-tablet yung gamit ko eh. PowerPoint. I don't know, it might be eating up a lot of bandwidth. Kaya ko ba itong percent using what? Meron sa inyo? Wala pa rin sa akin. Sa aking second screen.
Wala pa po, sir.
Sir, wala pa rin po.
Thank you. Ano ba yan? Hindi tayo makapag-quiz niya. At masaya naman kayo, ano? Ayun, finally. Nung lumabas siya, nag-unshare naman ako ng screen. So, kailangan ko lang maging patient. Okay, there you go. So an ODE in two variables is linear if it can be written in this form, right? Pag sinabi nating linear, alam niyo naman pag linear, degree 1. Walang exponent na mas malaki kay 1. Pero sino dapat yung walang exponent na mas malaki kay 1? As long as the dependent variables, ibig sabihin sa example na to si y, at saka yung kanyang mga derivatives dapat ay walang exponent na mas malaki kay 1. We don't care about how the functions involving only x look like, right? Kasi pwede ko silang isipin as constant coefficients. Or pwede ko silang i-consider as coefficients of the dependent variable. Alam kung anong itsura ng mga terms na may x lamang or mga factors na may x lamang. Ang titingnan ko para ma-consider kung siya ay linear or hindi ay ano yung exponent ni y prime, ni y triple prime, hanggang dun sa highest order derivative. Pag yung si y at saka lahat ng derivatives niya, ang exponent lamang ay 1, linear yung ating ODE. Kapag ka merong isa dun sa mga derivatives o si y mismo, merong exponent greater than 1, then that is a non-linear ODE. Or kapag ka nag-mix, kapag ka meron kang y at y prime, or y, or any of its derivatives that are multiplied together sa isang term, hindi na rin siya linear. So, ang usapan dapat bawat derivative hiwa-hiwalay, si y nakahiwalay din. It doesn't matter how their coefficients that depend only on x look like. Wala tayong pakialam sa itsura ng mga x's. Basta dapat si y at saka yung mga derivative niya ay hiwa-hiwalay at walang exponent na mas malaki kay 1. For instance, siyempre mabagal na naman to. Ayan, medyo mabilis siya ngayon. This one is a linear ODE because look at y and its derivatives. Third derivative, walang exponent, wala akong pakialam sa coefficient, so that's fine. Second derivative, siya lang yung may y, wala akong pakialam kahit may 3x squared ako na quadratic term. This guy is quadratic in x. Pero yung derivative, the derivative of the dependent variable, second order siya, pero wala siyang exponent, so this term is still linear with respect to the second derivative of y with respect to x. And then this guy, y lamang yung involved, walang exponent, doesn't matter kung may katabi siyang x, tapos si y at saka yung mga derivatives niya, hiwa-hiwalay na term, tapos meron tayong forcing term na x squared, everything looks good. None of the derivatives of y or y have an exponent greater than 1. So yes, this is a linear ODE. Okay. Next example, y triple prime plus 3x squared, y double prime minus xy equals x squared. Ano yung may mga dependent variable? Y triple prime, y double prime, at saka y. Hiwa-hiwalay sila, hindi sila nagsama-sama sa isang term. Tapos wala silang exponents na mas malaki kay 1. So it doesn't matter how those with x's look like, this is still a linear ODE. Right? And then, yeah, andaya pala. Examples at saka non-examples yung nakalagay. Pero, yeah. Now, examples of non-linear ODEs. Paano ko matatanggal yung annotation na ito pala? Okay. Non-linear ODEs, y prime equals x. Alright? Anong na-violate dito? Nagsama si y at saka yung derivative niya sa iisang term. Right? So this is non-linear in the dependent variable because y and one of its derivatives commingled in a single term. Another nonlinear ODE, y prime equals sine y. Why do you think this second example is nonlinear? Bakit nonlinear yung number 2? Y prime equals sine y. Hindi naman nagsama si y prime at saka si y. Mali pa rin pala yung sabi ko kanina. Wala rin namang exponent greater than 1 si y. So I need to amend what I said earlier. Bakit ito ay hindi linear? Mali yung sabi ko kanina na basta walang exponent greater than 1, siya ay nonlinear. Kasi siya ay linear. Itong number 2 ay nonlinear. Bakit siya naging nonlinear? Despite y having exponent at most 1. Nonlinear siya kasi si y nasa loob ng sign. Alright? Ang usapan kasi dapat ganito yung itsura niya. Right? So dapat yung y ay y on its own lamang. Hindi siya pwedeng nasa loob ng sine, nasa loob ng cosine, nasa loob ng exponential. Alright? So dapat ganito lamang yung itsura niya. Alright? Is that clearer? Nasa isip ko kasi kanina polynomials lang yung pwede natin i-consider. Pero yun nga pala, pwedeng may transcendental equations. So dapat si y on its own, si y prime, and then all of its ordered higher order derivatives, tapos walang exponents, at wala ring transcendental function involving the dependent variable y. Right? So kaya nonlinear yung example number 2 kasi may transcendental equation involving the dependent variable y. Dapat linear lang lahat ng mga expressions involving the dependent variable y or any of its derivatives. Okay. The third example is not linear because although meron ka ditong y, tapos nakahiwalay siya kay y prime, si y prime merong exponent. It is raised to the second power. So this guy, this example number 3 is a what? This is non-homogeneous. Non-homogeneous siya kasi meron kang forcing term na x after you write it in the form earlier. So siya ay non-homogeneous. Tapos siya ay first order. First order siya kasi ang derivative na highest order na nakikita natin dito ay 1. And it is non-linear. Non-linear siya kasi si y prime may exponent na 2. Merong non-linear function involving one of the derivatives. Okay? Is that clear? Tayo papalapit sa quiz. So this is your time to ask clarificatory questions. Oh, quiz na pala. Sabihin ko ay papalapit na tayo ng papalapit sa quiz. Any questions before we go to the quiz? Wala na? Sige nga, try natin. So you can open another tab and then put it side by side with your Teams app. Gamit tayo ng Slido. So open kayo ng browser or if you have your phones with you, pwede ring via phone. Kaya lang, anong nangyari? Ayaw niya mag-load. What happened? Sorry guys, having some technical issues here from my side. Okay. So So, punta kayo dito. So go to slido.com and then join the session number 1375348 or scan this QR code. Gumagana yata tong QR code na to. So try this and then let me see if I can. Wait now. Yeah. Kailangan pala maging patient ako. So Slido. So join this, scan this QR code or go to slido.com and then join the session number 1375348. Tingnan ko kung sino na yung mga naka-join. Oh, by the way, dun sa pag-join, pwedeng paggamit yung first name nyo. Para pagre-record ko, alam ko kung kanino yung score. Ayan. So, antayin ko lang kayo. So, ilan tayo sa klase? Hindi ko na makita kung ilan. So, 17 tayo sa klase. So, antay pa ako ng konti. Yeah, kung feeling nyo may kapangalan kayo, palagay naman nung kahit yung first letter ng last name. Okay. Tingnan nga natin. Meron bang mga magkakapangalan? Mukhang wala naman, no? So, still waiting for 3 other participants. Okay, dalawa na lang. Yeah, tapos na naman yung klase. So, okay. Tinatry kong i-integrate itong Slido sa MS Teams. Kaya ako napili yung Slido kasi supposedly kaya ko siyang gawin on the Teams app. Kaya lang hindi ko pa siya makita kung paano siya gawin or kung kaya siya. Nag-email na ako sa ITC, pwede daw eh. Kasi akala ko ay hindi nila inallow na i-integrate yung Slido sa MS Teams. Pero hindi ko pa rin siya makita. But I'm hoping to make it seamless next time. Na doon na lang kayo sa MS Teams gagawa ng Slido. Ano? So let me see, 16. Sige, still waiting for another one. Or lahat na ba ito nang nasa klase? Hindi ko sure kung binilang ako ng Slido nun. Ayan, there we go. So, kompleto na tayo, 17. Okay, then I have some questions here and then you have 15 seconds to answer. And 18. So, sakto pala. All right. So, 15 seconds to answer. All right. So, ready? Okay. Question number 1. Yes, Zaira, you have a question?
Sir, nadoble po yata yung sa akin.
Okay lang,
Pero di
Zaira.
ko
Yung
po
isa na
sure
lang
kung-
yung sagutan mo. Yeah, no worries. Nga, no? Dalawang Zaira. Doon ka na lang sa isang magsagot. No worries. It's okay.
po.
All right. 15 seconds per question. Okay. Number 1. Is this a linear ODE? So ito yung ODE. Y double prime plus 3y prime plus e to the x, y equals 0. Linear ba yan or hindi? 4 seconds. Okay, everybody answered yes. And the answer is yes, of course, it is linear because si y double prime, si y prime, at saka si y hiwa-hiwalay. There's nothing happening to them. Hindi sila nasa loob ng transcendental equation. Hindi sila naka-raise sa ibang power, all right? And then even though we have e to the x, it doesn't matter because all we are looking for sa pagiging linear ay dun sa dependent variable, all right? Na walang komplikadong function yung involved dun sa dependent variable. Okay, good job, guys. I think you're warming up, right? So next question. Leaderboard muna. Pinakamabilis si Kiefer. All right, 11 seconds lang. Good job. Next one. Is this a homogeneous differential equation? Fourth derivative of y plus 3y plus sine t equals 0. Is it homogeneous or not? Okay, let's see. Medyo malaki yung pinagkaiba. 36% said yes, 64% no. Anyone care to explain their answer? Okay, Remember, para ma-determine kung siya ay homogeneous or hindi, kailangan makita natin anong itsura ng forcing term. The forcing term is the term that doesn't involve the dependent variable. In this particular case, we have sine t na walang involved na variable. So ibig sabihin, we have a non-zero forcing term. The forcing term is negative sine t. It is not identically zero. So ibig sabihin, this is non-homogeneous. The answer is no. Right? So I hope that's clear. So dun sa 36%, ano ba yan? Nabudol kayo, right? Or tiningnan nyo lang kung yung right-hand side yung naka-equal kay zero. Some non-homogeneous equations might be disguised na parang homogeneous na naka-equal kay zero, pero ang usapan dito kailangan nating tingnan yung forcing term. The forcing term being the term that doesn't involve the dependent variable. If it is not identically zero, then our equation is non-homogeneous. All right? Okay, yung cannot isolate y, ano naman yun, Victor? Hindi siya question of homogeneity. It's a question of pagiging explicit or implicit. So in this particular case, parang kaya ko pa rin namang i-isolate si y, yung highest order dun sa isang side, ano? So this is also, or this can be written in explicit form. Kasi pwede ko siyang isulat na fourth derivative of y equals negative 3y minus sine t, na yung highest order derivative ay naka-isolate dun sa left-hand side. All right? So, but this, again, is just a question of homogeneity. Okay? All right, third question. Which of the following best describes this ODE? Oops. Sorry. Kaya nating ulitin. Sorry about that. Okay, tingnan niyo yung ODE. I-reset ko na lang yung time. Kaya pa ba magsagot or hindi na? Sorry, fail ako. So y double prime, i-reset ko na lang. Y double prime plus yy prime plus y cube equals t. So again, I'll give you some time to copy the equation. Hindi pala nagkasya sa isang slide yung choices, ano? So ito yung equation. Sulat nyo na, copyahin nyo. And then hopefully I can give you some time to... Okay. Ito yung choices. Nakapagsagot na pala kayo. Linear homogeneous, n of order 3. Linear non-homogeneous, n of order 3. Non-linear homogeneous, n of order 2. Non-linear non-homogeneous of order 2. Actually, this is non-linear, non-homogeneous, and of order 2. All right? Sorry, medyo mahirap palang sundan yung question yan kasi more than one slide. Or mas madali ba siya makita sa slido.com kaysa sa PowerPoint ko? Kasi parang ang bilis nyo nakasagot eh, no? Okay. Question, next question. Any ODE is linear and of first order if and only if it can be written in the following form. True or false? Kapag ka meron akong ODE, siya ay linear at first order kung kaya ko siyang isulat in the form given on the screen. Okay, 75% said true. The rest said false. The answer is true. Right? Totoo siya kasi kapag ka first order ang isang ODE, ay kaya kong kung first order ng isang ODE, first derivative lang yung involved. Alright? So in this particular case, y prime lamang yung involved. And then siya ay linear, ibig sabihin dapat si y prime at saka si y ay magkahiwalay. There's no fancy thing happening to them. Alright? So dapat y prime at y lang na magkahiwalay yung makikita ko. It doesn't matter how their coefficients look like. Alright? So meron kang P of t rito, meron kang F of t na forcing term, so that's fine. Ang question na lamang ay, lahat ba ng first order linear ODE ay kaya kong isulat in this way? Probably you might be thinking, what if y prime has a coefficient other than 1? Kung si y prime, meron siyang coefficient, ba, meron siyang sine t y prime, pwede ko namang i-divide both sides of the equation by sine t. So magiging super komplikado nga lang ni P of t at saka ni F of t. But essentially, any ODE can be written in this form. Okay? So last question. Have you successfully installed MATLAB? Kasi nga siguro next meeting or at the latest Tuesday next week, we will do some exercises, some graphing exercises at MATLAB yung ipapang demo ko sa kanila. Right? So nakapag-install na ba kayo or hindi? Okay, 82% said yes, 18% said no. So dun sa 18%, kindly try to do it in the next few days. If you have some problems, just let me know, and then I'll be happy to assist you with it. Kasi yun yung ipapandemo ko, especially if you don't have any experience doing programming. Sa mga hindi pa nag-152 o hindi pa nag-174, I encourage you to use MATLAB. Kasi MATLAB yung gagamitin natin pang demo. But if you think you can translate the codes that I will be using in class into Python or your programming language of choice, then that's perfectly fine. It's just that I prefer using MATLAB sa demo. Kasi mas intuitive para sa akin yung MATLAB. Right? All right, so both are correct. And then congratulations si Christine, ang ating top notcher for today, getting 4 out of 5 and the best time. Okay. Oh, siya lang yata yung naka 4 out of 5. Bakit the hardest question, have you successfully installed MATLAB? But anyway, so I'll record this as our first quiz. So yeah. All right, so meron pa akong ilang slides na natitira. Probably I'll use the last 5 minutes and see how far can I go with this. Okay. Pero babalikan din naman natin to later when we go to the next chapter. Okay. So this is just defining what a solution to an ODE is. Medyo napahapian ko na to last week. Sabi natin kapag meron kang algebraic equation, ang ginagawa natin, we're looking for a number or a set of numbers that satisfies the algebraic equation. If we have a system of algebraic equations, we're looking for a set of tuples of numbers that will satisfy the given algebraic system. Now, when we're talking about ODEs, medyo kakaiba to. Kapag meron tayong ODE, we're looking for a function. So ang solution na hinahanap natin ay isang function. What type of function? A function that when substituted to the dependent variable will make an identity. Ibig sabihin, magiging true yung differential equation kapag yung dependent variable pinalitan ko nung solution. So formally, a function phi of the independent variable is a solution to this given ODE kapag si phi ay n times continuously differentiable. Ibig sabihin, si phi together with its first, second, until the nth derivative ay lahat ay continuous, and kapag totoo yung differential equation kapag pinlogin ko si phi for the dependent variable y. Okay? So yun yung kakaiba talaga sa ODEs. Ang hinahanap natin ay hindi basta number. Naghahanap tayo ng mga functions na nakakasatisfy ng differential equation. So to make it clearer, for instance, we want to show in this example that e to the power negative 2x is a solution of this differential equation. All right? Okay. Buti hindi ko dinelete yung solution. Kasi mahirap pala magsulat dito sa screen ng computer ko. But anyway, so e to the negative x, 2x is a solution of this equation. Now, dalawa yung conditions. Una, take note of the continuity of e to the negative 2x. Ang derivative ni e to the negative 2x ay puro exponential lamang times a constant. So, ibig sabihin, e to the negative 2x is infinitely continuously differentiable. Right? Kasi lahat ng derivatives ni e to the negative 2x, lahat ay continuous. Kasi exponential functions pa rin sila. So the first bullet is easily checked. Medyo komplikado yung second bullet. Dapat kapag lahat ng y's dito sa DE na to ay pinalitan ko ng e to the negative 2x, dapat totoo pa rin yung equation. So when you want to show that a given function is a solution of the ODE, then you select one of the two sides of the equation, Isang side lang yung laruin nyo. Wag na yung high school proving na sabay yung ginagawa yung dalawang side ng equation. So start with one side of the equation, plug in the proposed solution, and then simplify it. Hopefully you get to the other side. So magsisimula ako dito sa left-hand side. Isi-simplify ko yung right-hand side after plugging in e to the negative 2x for all the y's that I see, and then I'll try to manipulate whatever I get and hopefully get the right-hand side, which is equal to 0. So that's the plan on showing that this is a solution of the ODE, right? So para magawa to, ipa-plug in ko yung e to the negative 2x dito sa mga y's na nandyan. So of course, I need y prime and y triple prime. So I can start my solution by saying, okay, tinetest ko kung solution si e to the minus 2x, so siya yung gagawin kong y. Kung siya si y, yung y prime ay ito. Inompute ko lang yung derivative ni y. Kaya lang, kung babalikan nyo, yung left-hand side ng ODE, hanggang y triple prime yung kailangan ko doon. So kailangan isolve ko rin ano si y triple prime. Para ma-compute si y triple prime, kailangan kong dumaan kay y double prime. Alright? So ito si y double prime, ito si y triple prime, and then I'll use these ingredients to simplify etong left-hand side. Right? So gamitin ko lang, y triple prime is e to the negative 2x is that guy, minus 3 times y prime, but y prime is already computed as negative 2 e to the negative 2x. So there you go, y prime was replaced by the first derivative of the proposed solution e to the negative 2x plus 2 times e to the negative 2x. That corresponds to this guy. And I'm keeping my fingers crossed. I want that this will simplify to 0. Okay? Pero madali lang naman. Do the algebra. Negative e to the negative 2x. And then this guy will be what? Positive 6 e to the negative 2x. Tapos may plus 2 e to the negative 2x pa. So the last two terms will add up to positive 8 e to the minus 2x. And meron tayong negative e to the minus 2x kanina. So this is equal to 0. And 0 happens to be the right-hand side of the differential equation. So dahil lang nangyari, kapag pinalitan ko lahat ng y's by e to the negative 2x, I get an identity. That means e to the negative 2x satisfies the differential equation. Then we have proven that e to the negative 2x is a solution of the given differential equation. Okay? So madaling mag-verify kung ang isang function ay solution ng differential equation. Ang mahirap, humanap ng solution. And we will spend the rest of the course doing that. All right? Now, isang bagay about ODEs, hindi unique yung solution. Kasi kung babalikan ko to, you can try it on your own, pero ang e to the negative 2x, say plus 17, is another solution. Okay? Isa rin yung solution ng differential equation kasi pag kinuha mo yung first derivative nito, actually, solution ba siya? Yeah, hindi pala siya solution. Sorry about that. So, hindi to solution. Pero what I'm trying to say, so hindi siya solution, sorry. Buti napansin ko kagad. The thing about ODEs, hindi laging unique yung solution. You can find other solutions to differential equation. All right? So, ano nga bang general solution nito? But anyway, so makikita natin later kung paano kumuha o kung bakit nagkakaroon ng multiple solutions. But essentially, there could be more than one solution to an ODE, and often that is the case. So kaya ang ginagawa natin sa paghahanap ng solution ay general solution yung hinahanap natin. We're looking for a general solution, meaning we are looking for all possible solutions. And usually kapag order n yung ODE, yung possible solution natin, meron siyang n na independent constants na kasali. And we will look at this more when we go next meeting, when we look at parametric solutions to an ODE. Basta tandaan nyo lang, kapag order n yung ODE, may makukuha tayong infinitely many solutions, right? And those infinitely many solutions will depend on at most n independent constants. Now, if you want to get one special solution among the infinite number of solutions, ang tawag natin doon ay particular solution. A particular solution is one of the general solutions that will satisfy an additional constraint to the ODE. Pag naglagay ka ng isa pang condition dun sa ODE, posibleng makakuha ka na ng isang particular solution. Magiging isa na lamang yung solution na nakakasatisfy dun sa ODE. Usually, this is in the form of an initial or a boundary condition. Okay? So for instance, kapag ka meron tayong y prime equals 2x, alright? So alam nyo na, ano lang yung function ng derivative niya ay 2x. So the general solution here is x squared plus c. Because all you need to do is to integrate both sides para mawala yung derivative, right? With respect to x, or sulat nyo muna to as dy over dx equals 2x. Tapos multiply both sides by dx, so we get dy equals 2x dx. Tapos integrate nyo both sides, so makakuha tayo ng y equals x squared, pero integration requires us to add a plus c. So that means any solution of the form or any function of the form x squared plus any constant is a solution to the ODE. Kasi pag kinuha mo yung x squared plus 17, right? I-plug in mo siya para sa y dito, you'll get a derivative equal to 2x. So you get an identity. So ang x squared plus c, yun yung tinatawag natin na general solution. But if you will impose another condition to this ODE, hindi lang y prime equals 2x, but you specify what should be the function value at a certain number. For instance, sabihin ko, okay, naghahanap ako ng solution ng y prime equals 2x, pero dapat yung y of 1 ay equal kay 2, then you will get a unique solution, right? So this is what we call an initial or a boundary condition. Okay? Ang y of 1 equals 2. So, hindi na natin i-consider as a solution lahat ng equation ng itsura ay y squared, lahat ng equation ng itsura ay x squared plus c, or lahat ng functions ng itsura ay x squared plus c. Kailangan kong pumili sino-sino dun sa mga function of the form x squared plus c ang may function value na 2 when x is equal to 1. And actually, we can only find one, and that is x squared plus 1. Si x squared plus 1, yung tinatawag natin na particular solution. Right? So, we'll revisit this few remarks when we begin next meeting. Pero I want to end here. Okay? Ano yung gusto natin gawin in this course? Right? Meron tayong apat na bagay or apat na tanong na kailangan sagutin. Una, meron bang solutions? Okay? And usually an analysis of the operator for the OD will tell us that. But next question, ilan yung solutions ang meron? Right? If it's an ordinary, if it's an ODE lamang without any condition, then most likely we will have infinitely many solutions. But if we impose a boundary condition or an initial condition or some other constraints, then we might get more than one solution to the problem or more than one particular solution. Next question ay, what are they like? Ano yung itsura ng mga solutions na yun? So we will be doing some qualitative analysis. And for the qualitative analysis, we will be looking at direction fields, isoclines, and we'll be looking for graphs. And usually here, we will implore the help of some computing softwares. Ano? Papagraph natin yung direction fields para makita or para ma-describe ano yung itsura ng mga solutions. And then next question is, how can we represent them? All right? So dito na papasok, paano natin isosolve yung mga ODE? Or kung hindi natin siya kayang isolve symbolically or isolve by hand, can we ask a numerical method to solve the solution for this? And then how do we present the solution? Should we present it as an analytic function? Or can we represent it as a table of values or as a graph? So yun yung fourth question na i-consider natin. Most courses will only focus on the fourth aspect. Ano yung mga solutions? Ano yung itsura ng mga solutions ng ODEs? But my hope for this course is we will not short sell the theory. All right? So gusto kong makita ano tong apat na bagay na to. They are interconnected, and this will give us a clearer picture about the ODE we are considering. All right? So we'll end here. Sorry, 5 minutes overtime na ako. So, but we'll revisit some of the last few remarks from this set of slides. So, do you guys have some questions? Yeah, sorry about that, Dino. Yeah. Napansin ko nga, yung 15 seconds pagbabasa pa lang ng question. I'll be more what? Generous about the time next time. Sige, yung quiz ngayon gagawin ko na lang bonus. Ano? Bonus na lang siya. Hindi ko nalalagyan ng over. Zaira, you have a question?
Sir, ask ko lang po kung ano pong pinagkaiba ng MATLAB online sa naka-install po and kaya po ba ng online lang?
Parang wala sila masyadong pinagkaiba. Pinagkaiba nila ay anong computing resource yung ginagamit nila. I think yung online, ginagamit niya ay yung online servers ng MATLAB. So pag nagpa-compute ka sa kanya, yung cloud facilities ng MATLAB yung ginagamit mo. So if you have a good internet connection, then that's okay. Pero I suggest i-download niyo yung offline version, right? Lalo na kung yung laptop niyo naman medyo okay yung RAM at kaya mag-run ng simulations. Ano? Siguro kung 8 gig yung RAM, sobra-sobra na yon. Kasi hindi naman tayo mag-run ng super lalaking systems. Ano? So, mas okay na i-download yung offline kasi para hindi nyo kailangan mag-connect sa internet if you want to run something. Pero kung hindi kaya ng computers nyo, pwede rin naman yung MATLAB online. Okay? So it doesn't matter. Pero hindi naman ganoon kabigat yung gagawin natin. Hindi kasing bigat nung sa 174 yung gagamitin natin. So either is fine. But I suggest you do you download the offline version. Para hindi nyo kailangan mag-connect sa internet, sayang yung bandwidth. Ano? Any other concerns? Aside from yung MATLAB, saka yung ang haba ng question, hindi kaya nung quiz. So bonus na lang yun today. Ano? And then before we leave, lahat ng mga sumagot verbally, pwedeng pa-comment dun sa chat box para mabigyan ko rin kayo ng bonus points for today, right? Yung mga nagsalita kanina. Yung mga nagsagot via chat, I'll give you recitation points as well. Pero makikita ko na naman yung pag inisa-isa ko yung chat. Pero yung mga sumagot lamang verbally, nag-on lang ng mic, paki-comment naman sa chat box, alright? So with that, I think we can call it a day. Sorry for the overtime. So takbo na kayo sa next class nyo. So thank you for coming today, and we'll see each other again on Friday. All right? Bye, guys.
Thank you, sir.
Thank you po, sir.
All
Thank you,
right.
sir.
Thank you, sir.
Thank you po, sir.
Thank you po, sir.
All right. You're welcome.